All right, friends, here we go. Now we are going to turn around and we are going to write the equation of the line that passes through these 2 points in point slope form. In order to do that, remember we need to get the slope and we need to use a point. Okay? Get a slope and use a point. Now in these scenarios, if you notice, we're given 2 points. We don't have the slope, so we need to turn around. We need to get the slope. In order to do that, we can turn around. We can calculate the slope using the slope formula. We can go here and start dropping the stuff in. So -3 goes for the y coordinate of y2, 5 being y1, 2 being x2, and 2 being x1. When we calculate this, -8 over 0, that is an undefined slope. Now, this is one of those scenarios where it's kind of interesting and kind of difficult to remember. But when we have an undefined slope, we end up having a vertical line, which is an x equals equation, and we use the x coordinate that's given. So what's interesting is we really don't have a true point slope form for this one because, you know, there's no real slope. It's an undefined slope. So we just write it x equals 2 and leave it, and we consider that point slope form in this case. Now, when we take a look at number 2, if we go ahead and try to calculate the slope again, we're going to have a very similar issue, but it's kind of the reverse situation. So when we drop the 1 and the 1, and drop the -4 and the 7, we get 0 over -11, which becomes 0, which is a slope of 0, which means it's a horizontal line. If it's a horizontal line, it's a y equals equation. It's y equals whatever the y coordinate is. One way you can identify that before doing any real calculation is notice that the y coordinate in both of the points are the same. So that means we're going to have one of the funky situations. In this case, it's a horizontal line. Okay, let's go ahead and drop through numero 3 into number 3. If we go ahead and we find our slope, I'm going to find it off to the side here. So we're going to go 3 minus 0. -4 minus -1. We have a minus situation, so it becomes plus. We have 3 in the numerator, and in the denominator, it looks like we have -2. That becomes the slope we're going to use. Now, the question is, when we drop it into point slope form, what point should we use? It actually doesn't matter at all. We can pick either of the points that we want to use. When we go ahead and do that, I set it up like that, as you see on the screen, and we're going to drop in 3 over -2 as our slope, or -3 over 2, or -3 over 2. All of those three things work out fine. Then we're going to pick one of the 2 points to work. I kind of like always grabbing the one that's listed first, just out of habit. It becomes a plus. Y equals -3 over 2, x plus 2. This would be our point slope form if we use that first point. You could also have it with the second point if you wanted. Both of these work. Both of those work as correct answers because both of those points end up being on the line. If they're on the line, we can use it in point slope form to represent the equation of the line, the equation that generates all the points when you put them on a Cartesian grid. Give you the picture of the line. Okay, so let's go ahead. Number 3. We're going to turn around. We're going to skip this one. Or number 4. We're going to skip 4. Now let's jump into numero 5. Numero 5 says we have 2 points here. We've got a bunch of characteristics to find about this line. In particular, we need to find the slope. We need to find the y-intercept. We need to find point slope form and slope intercept form. So let's start digging it out. If you remember, we're going to pretty much start by calculating the slope if we need to. Then we're going to put it in point slope form and convert it into slope intercept form. That's kind of the game plan that we're going to use, my friends. So let's do it. So first, calculate the slope. M equals y2 minus y1 over x2 minus x1. We drop these minuses in here. If you want to label the points, that helps too. That's a good suggestion to kind of help get you perfect at this. 4 goes in y2. Y1 is 1. X2 is 2. X1 is 3. Now we go ahead and simplify that. So we get 3 over -1, which becomes -3. That becomes our slope. Now we don't have our y-intercept listed anywhere, so we can't just drop it on that line. In order to get the y-intercept, we'll first drop it in a point slope form and then convert it so that we can see the y-intercept, okay? So now let's drop it into point slope form, x minus. So we're going to take either one of these 2 points work. So I'm going to take the first point, so x goes with x, y goes with y, and then we have our slope that we found of -3, so we're going to put that in as well. That becomes our point slope form. If you turn around, now we're going to turn around and find our slope intercept form. To do that, we're going to convert this by distributing the -3. So we get -3x plus 9 minus scenario. Then we're going to add 1, and we get y equals -3x plus 10. This becomes our slope intercept form. And the great news is no matter which one of these two we use to graph at the right, we're going to get the same line. And I'll illustrate that for you. This first version, when I use point slope form to graph it, I notice that the x coordinate is 3 and the y coordinate is 1. So I'm going to put a dot there. And the slope being -3, I'm going to go down 1, 2, 3, right 1. Okay. Now we're going to turn around and use the ruler and get that graph nice and perfect as possible. Okay, so now there we have the graph of the first equation, or the first version of this linear comparison between x and y. Now we're going to graph the second one. Y equals -3x plus 10. So notice our y-intercept, our b, our beginning is going to be 10. Notice how that drops on the line. From there, we're going to use our slope, -3, right 1, 1, 2, 3, right 1, and we're again on the line, again on the line, again on the line. We keep putting more and more dots on the line if we keep that slope, which means we did both of those two forms correct. Let's go ahead and do the next problem. To do the problem, make sure we read the description first and then move on from there. Write the equation of a line that has a slope of 1/2 that passes through the point 3, -2 in point slope form, then graph the line. I also want you to in slope intercept form as well. Okay, here we go. In this case, we already have the slope, so that's nice. We're just going to drop it on the line. 1/2 there. We don't have our y-intercept, so we can't just drop it on the line for b. But what we can do is we can put it into slope or point slope form first and then calculate that. So whenever we do point slope form, we like to start in that setup. Okay. And then let's go ahead and drop in the parts. So 1/2 being our slope. And we have x being 3, so we're going to draw that where x goes. And then y being -2, so we're going to drop that where y goes, -2. But we want to take that, that's a minus scenario, so we're going to turn around and just erase that and change that into a plus, okay? All right, don't know why the 2 disappeared. Okay, so now we have our point slope form. Now we want to convert it into slope intercept form. To do that, we distribute the 1/2. So we get y plus 2 equals 1/2 x minus 3/2, because 1/2 times 3 is 3/2. We have the x or the minus. And now let's turn around and solve it for y to get it into slope intercept form. -2 minus 2. We're going to get y equals 1/2 x. Now we're going to get a fraction here, and that's totally okay. That just happened. So we're going to do -3/2 minus 2 over 1. To subtract those, we're going to get common denominator, 4 over 2. -3 minus 4 is -7. So we get -7/2 as our y-intercept, which I know that that's a little weird. That's a little funky, but that's okay. That's the answer. So let's turn around and graph this. We're going to graph 3, negative 2. And we're going to use our slope of 1/2 from there. So 1/2, positive 1/2 means go up 1, right 2, dot. And we're going to reverse that, down 1, left 2, down 1, left 2. And notice how where those dots end up showing up anyways, we have a situation where it's not crossing perfectly, right? It's not crossing the y-axis perfectly, but that's okay. We ended up getting a -7/2, which is -3.5, which is about where it crosses anyway. So that's fantastic. We did it right. Take a look in the next video to see the next problem. Peace.